Right, so once again, statistics is a branch of mathematics that deals with the collection, organization, of data. So we first have class intervals. So a class interval is a group or range of values used to organize data in a frequency table, right? Okay, that's what a class interval is. So class intervals will be like, for example, like if you have, like say you have 1 to 10, the values 1 to 10, this is a class interval. Then you have 11 to 20, these are class intervals, right? Class intervals, right? Then you have class limits. So the class limits are the smallest and largest values used to organize the class interval, right? That is what class limits would be, right? Smallest and largest. Okay? So the smallest would be the smallest value would be the lower class boundary. Not boundary, sorry, limit. All right? So if we deal with like the class interval 1 to 10, all right? 1 will be the lower class limit, and then 10 would be the largest value, which is the upper class limit. All right? Okay, upper class limit, lower class limit. Now we're going to deal with the class boundaries. So class boundaries are the true limit of a class interval. They remove gaps, right? So these class boundaries, they remove gaps between consecutive classes and are used especially for continuous data. So what I call class limits, basically what we deal with in CXC, I call class limits the 0.5s. So I call them the point, all right, or you would 0.5s, right? So if I have, like say a class interval 1 to 10, And then I have another one, say from 11 to 20, then 21 to 30. So somebody trying to come in, right? My upper class boundary for my first class limit would actually be 0.5 less than this lower class limit here. So here will be 0.5, and then 0.5 above 10 would be 10.5, right? So this will be your upper class. No, this is your lower class, sorry. So for the first class interval, this will be your lower class boundary. That's this. And for the first class interval, 10.5 will be your upper class boundary. Class width would be the upper class boundary minus the lower class boundary. 20 bags of sugar were weighed. The weights to the nearest, well, the weights to the nearest kilograms are as follows, right? This is 20, right? How much is this? 1, 2, 3, 4, 5, 6, 7. 7 twos are 14, 14 and 6 is 20, right? 20. So complete the cumulative value frequency table for the data shown above, right? So for those who forget what a tally is, this was actually a CXC question, eh? For those who forgot what a tally chart is, that's basically where you put the 4 strokes and then 1 across. How many weights between 1 and 10? 2, did you say 2? 3. Right, so I want to cross it out. So 1, 2, 3, right? So you put in 3 here. 1, 2, 3. And also here, you put in 3. Everybody good there? So we go in. How many numbers between 11 and 12? And 20, sorry, 11 and 20. 1, 2, 1, 2, 3, 4. Correct there? 4? This will be 5. Everybody good with this table? That's how easy we do this table, right? We start with the easiest question, obviously, right? So we go down here now. For the class interval 21 to 30, that's the only class interval we focusing on, right? State the upper class boundary. So who can tell me what the boundaries are? I gave you all that definition above. What my boundary is 0.5, excellent. So, as I told you before, anytime I hear boundaries, think 0.5s. So my upper class boundary would be 30.5. It will be 0.5 more than this 30, right? So it'll be 30.5. That's my upper class boundary. Then we have to find the class width. What is the formula for class width? Somebody hit me. We write the formula because we want it to stick. What is the formula for class width? Upper class boundary minus lower class boundary. Excellent. 20.5. Excellent will be a lower class boundary. Right? So 20.5 will be here. Right? 0.5 less than 21 is 20.5. 10. Excellent. So that will be my class width. My upper class limit plus lower class limit all over what, Sarah? Right. So 30 plus, what is my lower class limit? 21 all over 2, which will give me what? 25.5. Histogram is a graphical representation drawn so that the base of The rectangle represents a class interval. So the sides of the rectangle, of each rectangle, represent the class, supposed to represents the class boundaries, right? Okay. Another thing you have to know about histogram. All rectangular bars are drawn. Are joined. What drawn I'm talking about? Are joined. So that's my x-axis. Let me proceed to draw my y-axis. Okay. Right, this is your y. Y-axis. Right before the Christmas break, we did graphs and charts. So everybody's supposed to be efficient in these things, right? Right. So 10 centimeters to represent 10 kilograms on my x-axis and 1 centimeter to represent 1 bag on my y-axis. What is my x-axis? My x-axis will be the weight, right? Please label your axis. This will be a weight. 10, this is 0 here, right? Then 2 centimeters represent 10 kilograms. So you have 10, 20, 30, 40, 50, 60, 70, 80, right? I want to put this as 2 centimeters. 2 centimeters to represent 1 bag on the y-axis. So you're counting in twos, right? So you're going 1, right? So you're coming up here. 2 centimeters to 1 unit, right? So you're going 1, 2 centimeters again, 2, 3, 4. Okay, you only had to go up to 6. 6 is the highest bar. Now let's go up to 8. Right. So, everybody good here? Let me know if all are good. What is my y-axis representing? Let's see what my y-axis is representing. That'll be the number of bags, right? Number of bags. Let me put it here. Number of bags. Please label my axes. You lose marks to these things in CXC, yeah? My first class interval would be 1 to 10. So we want to draw that bar of 1 to 10, and it's going up to 3. 3 is the number of bags, right? So 1 to 10 would be the class interval, and then you're going up to 3. Okay, so let's go down. Right. So watch it there. Be very, very careful when you're drawing this, right? If you join it from 1 to 10, you are actually drawing on the class boundaries, right? So for the class interval 1 to 10, the lower class boundary would actually be 0.5. Now here would be 1. Right here would be 1. Okay? So 0.5 would actually be in between here. So watch it. So 0.5 would be boom. You're going up. Go up in between here. All right. I think I have it there. That's all, man. I could shift this. This way your pencil ought to be sharpened pretty good. Right. In between 0 and 1, you reach up to 3, you go across, and you're coming down on the lower class boundary. Upper class boundary, sorry. Which would be 10.5. That's where you're coming down. Boom. In between there. right? That's the first bar, which is going to represent the first class interval, right? We go now. The next class interval would be 11 to 20, and the number of bags would be 4. So 11 to 20 would be 4. Now watch it. For 11 to 20, the lower class boundary for the class interval 11 to 20 would actually be same 10.5. So this same line here, you're going up to 4. You don't draw a new line. It's the same line going up to 4. Well, you just extend the line in all the case, right? Then you go across and you come down on the upper class boundary for the next class interval. What's the upper class boundary for the next class interval, guys? Which is 11 to 20. What is the upper class boundary? Who could tell me? For the class, excellent, 20.5. Excellent, Jonas. So you're coming down on 20.5. Boom. All right, everybody get it? Just raise your hand if you're still not understanding. Raise your hand if you're lost. I want you all to draw the rest. 21 to 30, right? So, well, we on the lower class boundary here, which is 20.5, but what we going up to, what was the highest? What is the amount of bags for that class interval? 5, right? So we going up again. Okay, we going up. So the same line, I would just extend it here, but you all know what to do. Hey, anytime I touch that, going mad, boy. All right, let me just leave that there. All right, so watch. I extended it here. All right, so we're going up to 5. Boom. Then we coming across here, bang. All right. I find graphs just take long to teach, boy. So much intricate things, boy. All right, I'll go across here. Boom. She now get up, boy. Right. And we coming down on 30.5. Next one. What's the next one? Let's give me how much it went up to. The next one. 31 to 40. 6. Good. So we're going up again. Up to 6. Bending off my line again, but I gotta undo this. All right. So we're going up to 6. Boom. All right. We coming across. All right. And then we going down. Anybody else not seen my screen? All right. All right, so we're going down. We're going down to 40.5, eh? All right, what's the next one, guys? 2. So I'm going quite on here now. 2. So you're just coming from here now. You're not drawing no new lines on that side. You're coming from here, then you're going down here. All that is a straight line, by. The cumulative frequency distribution of the volumes of petrol needed to fill the tanks of 150 different vehicles is shown below, right? So I just want to let you all know what what cumulative frequency is right here. I'm going to give you all a little note. Cumulative frequency. Right? So cumulative frequency is the total frequency obtained by adding successive class frequencies up to and including including a given class, well, all classes. Right? So this basically means that your first frequency, they did not give us a frequency column here, but your first frequency would have been 24. Your second frequency would be 59 minus 24, which will give me the second frequency. This is your cumulative frequency, which is obtained by adding, coming down. You all hear me clear? I find I lose you all for a while there. Right, good. So for the class interval, this question is almost identical to the one we had above. They want the lower class boundary for this class interval. What is the lower class boundary? 30.5. Excellent. 30.5. What is the upper class limit for that class interval? Somebody, Isaiah, your mic. What is the upper class limit for that class interval? Anybody? Upper class limit, not upper class boundary. Eh? Anybody? Come on, quickly. 40, excellent. 40, excellent. Right? Then class midpoint. Your class midpoint. Somebody give me the formula now. I want to remember these formulas, so let me write it.
Upper class limit plus lower class limit divided by 2.
Plus, remember it's plus, eh? Lower class limit all over 2. Right. Upper class limit would be, right. Your upper class limit would be what? Come on, you all belt it out. Upper class limit.
It's 40.
40 plus lower class limit. No. 30.5 is not your lower class limit. 30.5 is a lower class boundary. And what is to be equal to? 35.5. Remember to work out the top first, then whatever you get, then you divide it by 2. Right? Be clear on that, please. Right? So we go into our class width. Somebody remember the formula for class width? I don't remember it. Formula for class width. Upper class boundary.
Take away lower class boundary.
Divided by anything?
No.
Right, good. All right. So somebody hit me. What's my upper class boundary for that class interval we consider? 40.5, excellent. So it's 40.5 minus 30.5, which will give me 10. All right, everybody good there? Everybody good there? How many vehicles? Sorry, y'all want to write? Anybody wants to write? All right. How many vehicles were recorded in the class interval 41 to 50, right? So we're going up here. So this class interval 41 to 50. Here what is how much vehicles we will have in that, right? I'm going to draw my frequency table, not frequency table, sorry, my frequency column. So let me put frequency. Right. So the frequency for the first one would be the first number here, it should be 24. Here would be 59 minus 24, which will give me what? Somebody calculate that. All right. How much?
35.
Right. Here will be 101 minus 59. So here's 35. Here will be what? 42. So these will be the frequencies of each one, right? So here will be 129 minus 101, which will be 28. And then here will be 150 minus 129, which should be 21.
Yes, sir.
Right, 21. Okay. So this here would be my frequency. So we're looking for the class interval from 41 to 50. So the amount of vehicles in that class interval would be 28 vehicles, right? 28. Right, 28 vehicles. Right, so we go in here now. They said a vehicle chosen at random from the 150 vehicles, right? If a vehicle is chosen, what is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters, right? Leave your answer as a fraction. So we want the probability of more than 50.5 liters, right? Greater than 50.5 liters, right? So the probability of getting a vehicle from the 150 vehicles that has a, well, that has the probability, well, needs a probability, not probability, sorry, needs petrol of 50.5 liters or more would be 50.5 liters or more, be how much vehicles? Who could tell me? Let me see who could figure out that. How many people, how many vehicles need 50.5 liters or more? Right. 50.5 would actually be the lower class boundary for this class interval. So we're talking about all the vehicles in this class interval here, right? Those vehicles are not 150, right? 150 is a cumulative frequency. The vehicles in this class interval would actually be 21. So it'll be 21 over 150, which can be broken down to what? 3 into this is 7. 3 into this is 50. So it could be written as 7 over 50. Okay, so let's go. So this will be 10, 20. Go 2 centimeters to 10 units, right? 20, 30, 40, 50, 60, right? And this is your x-axis, and it represents your x-axis as well, your liters. X-axis would be liters, volume in liters, right? So this will be my volume in liters. All right, everybody good there? Volume in liters. Okay. So I want y'all have all the information. Right, so everybody must have all your class intervals and you must have your frequencies. Don't write on, you don't need to put on the cumulative frequency, your frequencies, right? And let's draw this histogram here quickly. So let's go. 11 to 20 would be 10.5 is the lower class boundary. We're going up to 24. How much we counted in here, boy? Here would be 25. 24 would be here. So you counted in ones, right? So let me go. You're going up Wait, what's that? $24. Right, so here, you're coming across here. You're coming across here to 20.5. And I come around here. Somebody give me what the next one was now. Please. What was the next frequency? Anybody, what was the next frequency? So we're going up to 35, right? So we're going up to 35. Bam, bam, bam. Boom. Coming across to 30.5, which is the upper class boundary. Going down here. Right, next one. Next class interval. Quickly. 42. So this same line going up to 42. 42 would be here. Here would be 42. Come across. And coming down. On 40.5. Next class interval. 28. Say coming from here. Here's 30. So 28 would be here. And I'm going across to 50.5. Coming down here. That's the last one, or a tad more? 21. Let me tell you something, eh? The masses of 60 parcels are collected at a post office were grouped, and recorded as shown in the histogram below. So, right? So you have your masses, this class interval here looking like from 1 to 5, because you see it's on the class interval 5.5. And then here look like from 5, no, not 5, this will be 6 to 10. Right? Then here will be 11 to 15, etc. Right? Complete the table below to show the information given in the histogram. Only one thing missing here. What's the number of parcels to 16 to 20? What would be the number of parcels from 16 to 20? Let me see who could see it. 16 to 20, what would be the number of parcels? 16 to 20, guys. Hold on, somebody now come into class. Right, let me go. So the only missing number here was the amount of parcels for 16, for the class interval 16 to 20, which was, wait. No, what more thing missing down here? I want to know. Hold on, let me send this whole thing down. Yeah, that's okay. Right. So your cumulative frequency for 21 to 25 will be 46 plus 11, right? 46 plus 11, which will give me what? 46 plus 11 will give me 57, right? And then what will be my number of parcels, or the height of the bar for 26 to 30? What is the height of the bar from 26 to 30? What looking like there? Anybody? You can actually calculate it underneath too, eh? You can calculate it here. You can do this cumulative frequency minus this one above here, and what you'll get? 60 minus 57, guys. 3. So 3 is the last frequency here. Okay? 46 plus 11 give me the 57. Then 60 minus 57 is 3. You could have also seen it in this bar above here. Right? In between 0 and 5 would be 2.5. So obviously here would be 3. Right? So that's done. On a graph paper using a scale of 2 centimeters represent 5 kilograms, on the x-axis and 2 centimeters represent 10 passes on the wire, we're going to draw the cumulative frequency curve for the data, right? So line up your graph there. Line up your graph, and then I'll show you all how to draw it there, right? So let's put in our graph page here. Right, so we're doing you all write on the table first. That's the first thing I want you all to write down. Right, so x-axis 2 centimeters represent 5 kilograms on the x-axis, right? So I go in here, I go and draw my x. Boom. Somebody mic on. Right, here would be 0. Huh? Yeah, put on. All right, so we go 2 centimeters to 5 units. So here will be 5. Here will be 10. Here will be 15. Here would be 20, 25, 30, 35, 40, right? Right. Then the y-axis will be 2 centimeters to 10 passes, right? Wait, the x-axis is what? The x-axis will be a mass, right? Mass kg. And let's go to our y-axis now. I think I should make a space here. Right. Here will be the y-axis. I'm going to put my scale here. Scale would be 2 centimeters to 5 kg. This will be the x-axis. And then 2 centimeters to 10 parcels. Y-axis. So we're going 2 centimeters to 10. So you're counting 10, 20, 30, 40, 50, 60, 70, 80. What's the highest cumulative frequency? 60. I don't even have to go so high. All right. So make sure I have this, please. So note. When drawing a cumulative frequency curve, we use the upper class boundary of the respective class interval and the cumulative frequency as the coordinates for each point. Right? Make sure you have that, and we're going to plot some points, and we're going to draw a smooth flowing curve through the points. Right? Let's go! We join this cumulative frequency curve, and then we call it a day, right? We'll do from 4 going down the road next class, right? So let's go. The first coordinates we're looking at would be the upper class boundary, which would be, what is the upper class boundary for the first class interval? Come on, let's get involved. Last question. Upper class boundary for this class interval will be what? The first class interval. Anybody? Upper class boundary for this first class interval, guys. I'll write the coordinates in the corner here. What is the upper class boundary for 1 to 5? 5.5 comma what? What is the cumulative frequency for that first class interval? What is the number in the cumulative frequency column? Come on, come on. Right, thank you. Next class interval now, 6 to 10. What is the upper class boundary? Anybody? 6 to 10. What is the upper class boundary for that class interval?
10.5.
Excellent. 10.5. What is the cumulative frequency for that class interval? Excellent. So that's my second coordinate, right? What is the upper class boundary for the next class interval? Come on. Upper class boundary. 15 point. And what's the cumulative frequency? 31. Excellent. Remember, we're looking at cumulative frequency, not frequency, which will be a parcels. This will be a frequency here. All right? Let's go. Next class interval. What is the upper class boundary? And my cumulative frequency. Next class interval. What's my upper class boundary? And then we have 30.5 and 60. Guys, I know the time we over the time, but this is not a time where we should rerun it away as soon as it's 11 o'clock. I want to finish this question, right? So there we go. We have all our coordinates here. Write down these coordinates, please. Write down each one of these coordinates. This is what we're going to plot now. Write down my coordinates.